As we saw in another segment, one of Lorenz's distinguishing features of imprinting from other forms of learning is the fact that it occurs only in a restricted period of time, a so-called critical period. The thing is, there is a critical problem associated with the critical period literature, and that is what we're going to be looking at in this segment. So, we're looking at the embryological literature here because that's where critical periods emerged in terms of how they were studied experimentally by the experimental embryologists who were around in the 19th and 20th century, starting in the late 1800s, the late 19th century. For example, I'll just name two people here. d'Arrest in 1891 had the idea for critical periods. Unfortunately, he did not have access to any kind of technology, not that there was much to have access to anyway, that would enable him to really investigate this. But he wrote about it. He felt that there was something that was really there that would be a particular time in life when embryos would be susceptible to different types of influences. Then along came Stockard in 1921. And by the way, there were even people who did things like Stockard at earlier times. I'm not going to name everybody. I'm just jumping ahead to Stockard, who induced abnormalities in fish embryos to see, are there times in prenatal development when the embryo should not be exposed to certain things because it could lead to abnormal development. And so he did things like change the temperature at different periods of embryological life, expose them to excess oxygen, to various chemicals and magnesium, for example, other things, a whole bunch of things at different periods of prenatal development. And he saw that, well, you had a greater effect at some times of prenatal development than at others for influencing the development of abnormalities in these fish embryos. And so, this kind of lives on to the present time in terms of translating things for humans. Women ought not be drinking alcohol or smoking or doing whatever while they're pregnant because of the ultimate harm that it can be manifest in the fetus. And so this goes back to Stockard and even before him to some extent. So there are some synonyms for critical periods that I think make more sense than the term critical periods, because the word critical, I think, is what is bad here. That bothers me a lot because it implies that you've missed the boat. If you don't encounter the stimulus during this restricted period of time, too bad, nothing is going to happen developmentally that's going to be good. Or, if you're dealing with bad things that you shouldn't encounter, whatever. You can translate that either way you want. It's just that there is this really critical, narrowly defined time that you can be influenced by a particular stimulus, good or bad. And, development's not like that. There may be times when you're more susceptible to being influenced than others, but you really haven't missed the boat entirely. So, sensitive periods is probably the best synonym. You'll also see in the literature optimal periods as well as periods of phase specificity. So you may come upon those terms. They're all synonyms for critical period. Sensitive period makes sense. Basically it's referring to the fact that, there might be some times when you're more sensitive to being influenced by something, but it doesn't mean that if you don't encounter those stimuli then that they'll have no influence if you're exposed at some other time, either before or after. So I think this is one of those cases where the way we refer to things, the words that we actually choose to refer to something does matter, especially in terms of the kind of conclusions one might tend to draw from certain experiments that may not necessarily be warranted. This is the methodological confound. This is the critical problem of critical periods. It's the critical period to test interval, because it's something that typically is not assessed in critical period experiments, and as we're about to see, it can be quite crucial. So here's the way the confound works. So basically, again, the typical paradigm for an imprinting experiment involving critical periods would be to expose an animal to one of two objects, isolate it from that object, and then test it to the object it was exposed to versus one it was not. Okay, and so question is, when are you going to do that exposure? Okay, that's what's critical. But that's the critical period to test interval, that red arrow, the time when you take away the stimulus, so you're no longer exposing the animal to that stimulus, to ultimately the time that you're going to test it. People have assumed, well, nothing important can happen there. It's outside the critical period, or what we were looking for in terms of a critical period. So why worry about that? Well, I think I'm going to show you some evidence. In fact, I know I am. That will give you some pause in terms of seeing that that can be a pretty important period of life. So here's the way the confound works. So you're testing for a critical period. Now, wherever we have this enlarged portion along this line, that is when you're going to be exposing the animal to a stimulus. So there's no exposure. You start exposure, keep it exposed, then shut off the exposure. And then you wait whatever period of time, depending on your experimental design, to test the animal at a particular age. Just call it age Z, okay? Just choose a letter here. So here's our critical period to test interval A. Now, then, you're probably looking at different times of life for exposure. It's pretty much like what Stockard did with his fish embryos. So instead of exposing the animal here, you'll instead wait longer in development and then expose it here. So that's our critical period to test interval B, and you're going to test it again at that particular age, the same age as you did up here. And then, the same here, you're just going to wait for another period of time to elapse before you expose it, and then you're going to have your critical period to test interval, and then, again, test it at the same age. What's wrong with this design? I hope it's obvious. The critical period to test intervals for each of these experimental groups is different. It has a different duration. Unequal intervals. But again, people have assumed, well, that's not important. What matters is what's going on during the period of exposure. One way to fix that, you could do this. You can make them equal intervals, but that means you're going to be testing them at different ages. So that potentially introduces yet a new confound to the whole methodological design. Different ages. It's the only way to keep the critical period to test interval constant, however. So no matter what you're doing with critical period research, you're faced with some huge methodological issues. But again, people have assumed there's no methodological issues, there's nothing to worry about. Well, let's see. Let's see if there is something to worry about. And you can just tell from the way I'm saying that there is. And let me show you what it is. And we're going to use as an example, I did a series of critical period, sensitive period, whatever you want to call it, studies involving alarm call responsivity in mallard ducklings. So you'll remember this from now multiple segments. And there's our infamous alarm call. Okay. And then you remember that ducklings freeze to it. They're all excited at first, but then as soon as they hear that alarm call, they become totally frozen like that. Okay, so the way we did these critical period studies was to use devocalized ducklings. So we devocalized them, of course, as embryos before they ever had a chance to utter a sound embryologically, and then expose them either while they were still embryos after devocalizing them, or as hatchlings, or maybe both, in both embryologically, I'll just say prenatally and postnatally, to the vocalization types that they would be uttering if they were not muted, if they were not devocalized. In other words, the sounds that other duck embryos were making. But we did this exposure at different points in time. And then we test them to see if they froze to the maternal alarm call. So they're exposed to different points in time via loudspeakers in the incubators or brooders if it's a postnatal situation to this particular embryonic call, which also the hatchlings make. It's basically the same call. Okay. And you might remember they make other calls as well, but we just picked this one. It was fine. So they're devocalized. Okay, they're devocalized as embryos, and they remain devocalized as hatchlings up to the time when they're tested, and even sometime beyond that, but we're not concerned with that. And then we're going to test them, of course, to the maternal alarm call to see if they freeze. Okay, so that's basically what we're doing. here's the summary of what we found. So notice they hatch, where I say hatch, okay, that which is actually day 27 of incubation. So our prenatal period is going to extend from day 25 and a half of incubation. They've already been devocalized on day 24, up to the time they hatch. And then the postnatal period of exposure is from the time they hatch up to the time they're tested at 12 hours of age. So here's our first group. They get both prenatal and postnatal exposure. So the thickened line means the same thing as I showed you in the earlier graph. So it's a period during which they're exposed, in this case, to the embryological call, the prenatal call of the other ducklings. Okay, so that they're exposed prenatally and postnatally. And guess what? They froze. No big surprise there. We knew that would happen just from all the other work we had done up until the time we did this study. But now we're looking for critical periods. So here's a group that's only going to get exposure to the duckling vocalizations prenatally and then no exposure up until the time they hatched. And those guys did not freeze. Okay? So obviously you know where we're going next. We didn't do the prenatal exposure. Instead, we exposed them to the duckling vocalizations after hatching up until the time they froze. They froze. Aha. Well, fortunately, we did not rush to this conclusion, but it would have been a conclusion that I think most people who do critical period research would have concluded, and that is that there's a postnatal critical period. But we did not conclude that. We looked at our data very carefully, and we noticed something rather striking, and you may have noticed it already because of the way I drew this graph. And that is the fact that both groups that froze had exposure to the duckling vocalizations up until the time that they were tested to the maternal alarm call. The one group that didn't freeze, there was a gap. There was that critical period to test interval of non-exposure. They didn't freeze. So we ran one more group, one more critical group in this critical period experiment. And that's how we did it. We tested another group at 24 hours of age that were exposed as hatchlings up until 12 hours of age, just like the group above that, okay? Now that group froze. And the result of that is that they didn't freeze to the alarm call. So, you know, if you're going to conclude there's a postnatal critical period, well, then that last group we tested should also have frozen, but they didn't. The most probable conclusion from this, I'm not sure it's the definitive one yet, but it is a probable one, and it can be tested actually a little bit more carefully. But basically, it refers to the roles of naturalistic observation that we saw in a different segment. There were 4 roles. And the role that I'm referring to here is not that we're dealing with a postnatal critical period, but instead we're dealing with a maintenance effect. Because exposure was necessary, experience was necessary for them to freeze. If you took away the experience, in other words, what happens in that critical period to test interval of non-exposure, then the behavior of freezing goes away. They're not freezing anymore. This is the most likely explanation. So, you know, the literature is kind of a mess when you think about it. The whole problem occurs in a lot of other species that have not really been tested directly in this regard, but sort of. And here's a study, for example, with rhesus monkeys and dogs that were trained to be nice to the rhesus monkeys. And so there were many groups in this study. I'm just going to mention 2 of them very briefly. The monkeys were exposed to their moms after they were born, and then they were separated from their moms for not a real long period of time, but they were then tested to their moms versus something else. I don't even remember what else. And of course, they chose their moms. I think I'll just mention yet another group. They were also exposed to siblings, and then they were separated from siblings, and then, of course, when tested, they chose to go to their siblings. Now, they were also exposed to these surrogate dogs, right? These are live dogs. And they were then tested after a period of separation to the dogs versus their mothers. Now, they were also earlier exposed to their mothers. Oh, and also to their siblings. So they were given all these tests, and in each case, they chose the dogs. They chose the dogs over mom. They chose the dogs over siblings. But the dog was the most recently exposed imprinting object. They were exposed to the other ones early. By the way, this also attests to the problem of irreversibility that I talked about in an earlier segment, because the rhesus monkeys had already formed an attachment to, in one case, their moms, in another case, their siblings, and now later they're being exposed to dogs, and now they're reversing their preference and actually forming a preference for the dogs, even over other rhesus monkeys. So basically, this speaks to the critical period literature in the sense that the exposure to the dogs happened at a much later age beyond what they thought you could actually form a preference for anything for, but they did. They chose the dog, so it was irreversible. It was allegedly outside the critical period, and so, it's you got to worry about some of the critical period literature, maybe all of it for that matter, because outside the critical period can be just as important and maybe even more important than what's happening inside the alleged critical period. But the literature, the human literature, the animal literature, is just loaded with critical period experiments that have not even considered this as part of the experimental design. I just think it's really, really a mess. And hopefully people will start to go back, reassess their data, see what they can do to maybe alter their conclusions a little bit, or at least add another group or two in there to see if they arrive at the same conclusions that they arrived at originally. If so, fine, but it needs to be looked at.